Hi, this is Lars Kreklau from Encodera, and today we're going to show you the content creation pipeline of Why Does It Spin, our debut title, which is released in summer 2014, so basically this year. We have chosen Blender as our content creation tool because it has a Python interface, which makes it quite easy to create specific tool for our game. So in this first tutorial, we will talk about the composition of a new level. And for that we choose a certain size of the level, which is now 10 by 10 tiles. And with that, a number of tiles is created and aligned properly. So let me choose a different viewport here. This looks rather confusing because we see two different kinds of tiling. The first tiling is just to get an imagination of the iPhone size. So each of these tiles has the dimension of an iPhone 4. So the user gets an impression of what will be visible on one iPhone screen. The other tiles are the environment tiles, and here we can choose a certain geometry, and in this tutorial we simply use chaotic bands, which have a quite chaotic trajectory and look rather random, but this is quite the right scenario for our type of game. So since this looks rather confusing, we just set these tiles invisible and start with the creation of the map outline. And for that we have taken the C implementation of Spiro splines from Inkscape and ported that to Blender such that we can easily use Spiro splines directly in Blender. And the use of Spiro splines is in the first moment not that easy in the beginning, but then once you get used to it, it's rather intuitive tool because you can generate very blobby and rounded shapes with a very small number of vertices. So in this small map here, I want to create or I want to start with a blobby area, and then later on I want to move to quite sharp hallway. So as you can see, the boundary is always perfectly rounded, and for our gameplay this is quite important because we have this continuously rotating stick, and using arcs is the most intuitive kind of shape that we can actually use. So what I want to do now is, as you can also do with different or with other types of splines, like for example with B splines or NURBS, you can also create sharp features, and this is also possible with Spiro splines. So you can select a number of vertices and specify them to be sharp. And now as I insert further vertices, I can create sharp features here in order to create, for example, a straight hallway. So you can also use, if you want to create a very precise map, you can also use the snapping of Blender, of course, but for now I'm creating a map freehanded. The next thing I want to do is I want to create a small rounded room right over here to fill up the empty space, and I'm doing so by creating another vertices, another vertex that creates a rounded shape here. And the good thing about Blender and its curve tools is that you can create several curves and they will get cut off each other. So if I insert another Spiro spline right over here, then it can be defined to be cropped or cut out of the first shape. So this makes the modeling quite an intuitive and fast process for such kind of shapes. So we can easily combine quite blobby shapes and using perfect arcs, as well as some areas in the map with very sharp features using these Spiro splines. So the next thing we do is, once we have designed our outline, we procedurally generate the level boundary using real 3D geometry that looks like a rope, and we create the physical representation. So this is basically the polyline representation of the Spiro spline that is used as our static collision shape here. And of course, one of the most important objects that needs to be placed in a map is the starting position of our rotating spin ship. And this one is represented as a circle, which is the approximate, or which is the size of the spin ship once it rotates or makes a full circle. So if I move it along the map, we will see that it will fit through the whole map. Okay, here is an area where it might get a little bit more difficult because you have to wait for the right moment to pass through, and also this area here seems to be quite manageable and easy to accomplish. So the next thing we want to do is to create the start and end regions, and for that we choose a different kind of object here. So we place a start region over here and the end region over here, and yeah, to make it more or better visible, I've created a simple button here to make these shapes rendered as X-ray and wire in Blender, so they are always visible. So these are the physical representations of the start and end regions. So once the user has left this region, the game will start, and once you have finished this labyrinth and moved your spin ship through this labyrinth, you will end up in the end region, and for that we also specify a certain end position here. So this is basically the position where the avatar gets moved as soon as it touches the end region. So this is where the map is finished and you are safe and has you have accomplished the labyrinth. So the next thing we could do is, to make it a little bit more interesting, we could insert knots, which are items that can be collected. So as you see, the button is still called coin because in one of our first versions of our game development we have taken a coin shape that is collected, but as you see that in many games we thought we could do something new, and so we made this knots which are unfolded as soon as you touch them. So we make a small trajectory here of knots. Later in this video you will also see the in-game graphics, so just stay tuned and wait for the end of this video so you see this game in action. So a more interesting element to be placed here in our Blender tools might be the moving cranes, which automatically adapt to the level boundary. So if I place them somewhere here, you see that it will automatically adapt its size accordingly, and it has certain properties. So moving crane takes an object and moves it back and forth along a straight line, and here we can specify, for example, the time it takes from left to right, or the time the object's weight on each side to move to the other side again, and some further properties. But most importantly, we can specify which kinds of elements are placed. So for now we just have the possibility to place crates, and when we create these items they are simply set next to each other automatically. So this is basically the gameplay of this first map we want to create. Oh, I completely forgot. So what we did with the regions is we designed the physical outline. So this is of course the important part for the gameplay, but for the graphical part we also need to compile the graphics representation. And what it does is it basically takes the physical representation and makes a Boolean operation with the level shape so that we can use a different kind of material in these areas here. Because our maps are arbitrarily shaped, a Boolean operation comes in quite handy. So we simply use the modifiers of Blender to achieve this. And as you will see later in the gameplay video, you will see that these areas will have some wavy material, and the rest of the map will have some tiling on it. So this is why we need some two-dimensional shapes here that represent these areas. So as a final step, we want to bring more detail into that map, and therefore we place so-called decoration objects on the boundary. And for example, we could load different kinds of chess elements that could be placed, or like, for example, let me see, what else do we have? Or like a car that looks quite nice here. So let's move it a bit downward to make it touch the boundary a bit more. And once you have found a setup, you can easily create lots of them along the boundary. And this makes it quite easy to raise the complexity. Once you have chosen a certain model, like for example, a castle for example, you can also use scaled versions, for example. Just set up the height and the size and the rotations along the boundary, and then you can easily create several instances quite fast. So what else do we have? Like, for example, we have a sphere. Could place a sphere somewhere over here. Okay, maybe also inside this circle here some spheres. And yeah, maybe also the spiral. So this is basically one of the most important things, right? Because our game is about rotating sticks, and the spiral is quite a nice shape for that, to represent rotating objects. So let's also use a scaled version here. So put some of these over here in this round way. And with that, you can easily create a lot of different objects. We have also, for example, inserted entangled letters. So they are entangled with with these bands here. So we can write some stuff along here. Like for example, let's write. Do we have Blender? So, okay, this one maybe should be erased, and this one maybe moved over here. So this is basically our first map, and you see the quite high complexity, which was created in just 15 minutes. So the last thing we need to do is define the rotation of the avatar, which is in our case, as you imagine that the avatar moves along this path here, it's more intuitive to let it move counterclockwise, so we define it to move counterclockwise. And maybe we also need to define some objectives for the map, like for example, let's say that the user has to collect a minimum number of these knots, like for example Okay, what would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, let's say 15 knots. That's quite an easy task. So let's say task 1 is 15 knots. Then let's make another easy task here for this tutorial and say that it's 20 knots. That's task 2. It's 20 knots. And as a final task, we say that the user has to collect all the knots. So where do we have it here? So task 1 is 15, then 20, and then all the knots. These are our objectives. And yeah, let's now have a look at the game graphics. And for that we need to export and start our engine. Yes, so right now we have imported the map into our engine and are ready to test it. So when we look around here, we see all the nice decoration objects, the spirals, the sphere, the castle, and on the bottom or on the floor we see the start region with this wavy pattern, with this animated wavy pattern. Now we see all the knots we placed around, and here comes the narrow area. So you see, okay, if you don't wait for the right moment, you will hit the walls like that. You see, you will not get through. So you have to wait for the right moment so that you can pass through. On the bottom we see the nice Blender letters actually. Now we encounter this moving crane, moving from left to right in a few seconds, so this is rather easy then. And here on the left we have this circular room with all the nice decoration objects around and the 3 spheres in the middle. Oh, actually a nicely colored spiral over here. So now we have collected all the knots, and let's finish the game. And we see that the little guy in the bottom left is quite happy because we have fulfilled all the objectives since we collected all the knots. And now we get a little firework. So if you like what you see, then follow us on Facebook, Twitter or Google+. Or you can actually also subscribe our RSS feed on our blog. And if you have any further questions or comments, please let us know by writing a comment to any of the social media platforms or on YouTube or in our blog.